Hello, my name is Klaus Lange, and I'm a Principal Program Manager in Azure. Today, I want to talk to you about blob storage and data protection, how to secure your blob storage. But first, let me describe a little bit about what Azure Blob Storage is. So blob storage is a PaaS-defined service that is produced in Azure that is designed for unstructured data storage up to exabyte scale at very low cost with a high level of control. We see 4 different categories of workloads using Azure Blob Storage. The first one is applications, both cloud-native applications designed from the ground up to use that scale and that efficiency, as well as lift and shift from on-premise for applications that are migrated to Azure from on-premise and then start to use blob storage. We also see analytic workloads such as Hadoop and Spark that use ADLS Gen 2 as the underlying file system that expands upon blob storage, providing directory and folder structure, as well as per object ACL and folder ACLing information. Third, we also see high-performance computing, including AI and ML, such as autonomous driving or medical-based solutions such as genomics. And fourth, we see cold data storage, such as backups, logs, video files, and other sorts of content, which most people assume would go to an unstructured data store. And that is what we also see as well with Azure Blob Storage. Now, when thinking about protection, I want to talk about how do you protect from a hardware failure or a regional loss. I also want to discuss how you would handle accidental deletion, as well as data protection. How do you protect the data that's at rest from modification or accidental or even malicious changes? And then last, we have a feature called immutable blob storage, which is designed for financial purposes as well as policy requirements, which requires the content to truly be immutable at a fine degree of control. So first, let me talk about how to think about protecting against both hardware as well as regional downtime. And for that, I want to discuss the different replication options that you would choose in your storage account for blob storage. Working my way from left to right, the leftmost has the least amount of durability, even though it's quite high, in that for LRS, locally redundant storage, we commit the write on 3 different drives in 3 different clusters before we acknowledge back to the application, such that even if we were to lose a drive or one of the hardware clusters that drive is in, your data would still be persisted. We wouldn't have any data loss whatsoever. Now, ZRS, zone redundant storage, expands upon that by making sure those 3 different drives are in different zones. So in that situation, even if we have a zone down situation, there's no impact to your application. You can continue to write and read from your application as if everything was operational. So it's a better option if you require a higher availability for your application at runtime. Now we have 2 dual region options, which basically adds on to what I previously talked about, where you want to protect even against a natural catastrophe impacting one of the Azure regions. And so for GRS, Geo-redundant storage, we copy the data after the commit from the primary site to a secondary site, and we make sure that those sites, in almost all cases, are at least 300 miles apart. And so that really does protect against an earthquake or other sort of natural disaster. Now, we also have, finally, GZRS, Geo-redundant, zone redundant storage, which combines a ZRS account on the primary region with an LRS account on the secondary region. So you get the same high availability of ZRS in the primary with the geo-protectedness of GRS to that secondary region. With that, I want to talk about protecting against accidental deletion, and there's different scopes to think about. All the way from the file or blob, how do you protect against those being deleted, to the container that they sit in, to the storage account, which contains the containers and the blobs. And so with that, I have a short demo to talk about all 3. So in this one, I'm going to go to my Canada East storage account. And the first thing I'm going to do is go down to data protection in the blob service. And when I look at my options there under protection, I can see soft delete, and I can specify the number of days to retain my deleted blobs for. And so in this case, I'm going to choose 14. And then I'm going to do the same thing for container delete. Now, the values could be different. I like to keep them the same. Now, we also have versioning as a little bit more of a tracking feature, which can expand upon the other features for protection. Now, if I go back in my account, I can also look at locks. So to protect a storage account from being deleted, I can set an ARM lock. So I'm going to call this delete protection. And I want it to be a delete lock to protect against deletions. And I can also add a note here if any other admin in my organization isn't really clear why this lock is there. I can add my name or contact information. I'm just going to leave a short message here. And now this lock is in place. Now with the lock in place, if I go back into that same storage account and I go ahead and delete it, it says it can't be deleted because there is a lock present. So now I've put in a pretty good speed bump where if I delegate control to my storage account and don't provide other people with the same admin credentials I have, I've now prevented other people from deleting my storage account. The second main category I want to talk about is access and security. How do you basically use RBAC, account key, and shared access signature? What does Defender do and how do you enable it? How do you ensure that HTTPS is enabled for all communication to my storage account? I will also mention that we have a private link functionality as well as a storage firewall where you can create network security around your storage account. So you can set up the storage firewall that limits access to only known IP address ranges or specific trusted services that you allow access to. And then last, there's immutability where you can set an immutability policy to prevent any delete or modification to your blob storage. So with that, I'll give a demonstration. So I'm going to go to my Canada East storage account. And the first thing I want to show is under settings, these access keys. And notice that they're in the plain text here. So I'm going to remove this after this demonstration. But the account keys is one way that you can authorize access to your storage account, but we don't really recommend it if you can help it. You can also rotate the keys directly in the UI. Now, besides an account key, there's also a shared access signature, which is a much better bet, where you can specify which service you're giving access to. You can also specify what permissions you allow, read, write, etc. And you also have control over exactly how long is a shared access signature going to be good for. And so the idea is that you basically craft it with just enough access and then specify HTTPS only would be my recommendation. And then you can hand out that shared access signature to customers. Lastly, there's role-based access control, which uses AAD identity. So in this case, I went to this IAM page, and I'm going to go ahead and add for Chris Green or all the AAD administrators within my tenant a specific role. And notice that there's owner and contributor and reader, which provides access across all different service types, or I have specific roles explicit for blobs. So in this way, I can provide just read access, for instance, or just contributor access. So I don't have to provide more access than is necessary to other people in my company. And so that provides a lot more control as well. So lastly, I want to look at this configuration page. And secure transfer should always be set to enabled, which means HTTPS is only used for transferring to and from my account. And then besides HTTPS and secure transfer, I also want to look down here. Allow public access. This basically toggles whether or not somebody can turn public access. This does not turn public access on. I just want to be clear about this. So this is an added feature or an added way to control whether you can even enable that on a container. So in this case, I don't want to allow public access to be enabled at all. So I'm just going to say disable to that. This allows me to control what's my minimum TLS version. TLS is the encryption protocol used with HTTPS. So I can also control that if I want to. If I was using retail or PCI compliance, I'd have to set that to 1.3. And with that, I now want to go to Security Center to show you how you turn on Defender. So from Security Center, it gives me a one-stop shop for all of the stuff that I'd want to do in this frame. So here I'm picking the specific subscription that I'm managing, and notice that Defender is off currently. And now all I have to do to turn it on is click on Defender on, and it enables all of that including that bottom check mark, which talks about the threat protection that is in place for Azure Blob Storage. So I'm going to go ahead and click that on and hit save, and now I have Defender on my storage account. It also does other things such as detect anomalous activity against my storage account and other protections that I really do recommend that people run in their storage account. With that, I will now lastly want to talk about immutable blob storage. So immutable blob storage allows you to set either a legal tag or a time-based policy that controls if a blob can be deleted or modified. And the policy can either be locked or unlocked. So in the case of a locked policy with objects under control, I'll add that you cannot delete the storage account, the container, or the blobs that are protected under that policy. And I'll also make a statement that if you're going to test this, to be careful that you don't go too far, because you might be stuck in a situation where you can't delete your test account, which has happened to me in the past. And so with that, let me give a short demonstration. So this time I'm going to go to a different storage account called West Central USK. And I'm going to go ahead in my storage account and create a container called test. And then within test, I'm going to go ahead and add an object called 512. It happens to be 512 bytes long. And then what I'm going to do is take a quick peek at it and go back to the storage account. And now I'm going to go to the container and I'm going to set an access policy. And here's where I set my immutable blob access policy. In this case, I'm going to set a time-based policy. And I'm going to set the retention for 1 day, because I do want to clean this up later on. And I'm going to go ahead and lock my policy. So we have a nice warning in there that says this is irreversible. And so now with this locked policy set and this blob that I just uploaded right beforehand, I'm going to go ahead and try to delete it. And it's failed due to the immutability policy. So now instead I'm going to go, hey, I just want to delete the whole container. Same thing, I get a deletion failure due to the immutability policy. And last but not least, I'm going to go to the storage account and I'm going to attempt to delete it. And I get the same failure. Due to a locked immutability policy, I cannot delete this storage account. So by doing this, I've protected against blob, container, as well as storage account deletion. So hopefully I've described how you can protect your storage account, pick the right redundancy level, and also set some of the specific security settings, as well as enable Azure Defender to protect your storage account. Please click on some of the links following for more information, and thank you so much for your time.